Hello everyone, welcome to IT Professional Learning for Security Compliance and Identity Fundamental course. My name is Zoran, I'm Senior Solution Architect and Senior Technical Trainer. This course provides fundamental knowledge of security compliance and identity concept and related cloud-based Microsoft solution and technologies. This course is intended for those who want to learn how Microsoft Security Compliance and Identity Solution can span across solution area to provide a holistic and end-to-end solution. Also, this course will help you to prepare and successfully pass Security Compliance and Identity Fundamentals SC 900 exam. This Security 900 course deals more with theory than practice. The knowledge from this course will help you to determine the direction of your future interest and learning about cloud security, as well as your overall security cloud journey. This course is first in the series of courses on security in Azure cloud environment. If you want to deeply learn how to design and apply security in Azure cloud environment, several courses from this series are available. Security 200, Microsoft Security Operation Analysis. Security 300, Microsoft Identity and Access Administrator. Security 400, Microsoft Information Protection Administrator. And Security 100, Microsoft Cybersecurity Architect. All those courses should give you knowledge to successfully pass those certification exams and also ability to successfully implement all cloud security solutions in your Azure cloud environment. In order to successfully follow and understand this Security 900 course, you should have general knowledge of network and cloud computing concept, general IT knowledge or any general experience working in an IT environment, and general understanding of Microsoft Azure and Microsoft 365. If you don't have this knowledge, I strongly recommend that you first take AZ 900 Azure Fundamental course or similar course such as AZ 104 for Azure Administrator. The free version of AZ 900 Azure Fundamental course will be available on this portal. If you still with me, let's get started. What we will learn in this course? This course is divided in 4 segments. First segment is describe the concept of security compliance and identity, which has 2 modules. Second segment is describe the capability of Microsoft Azure Active Directory, part of Microsoft Entra, which has 4 modules. The third segment in this course is describe of the capability of Microsoft Security Solution, which also has 4 modules. And segment number 4 describes the capabilities of Microsoft Compliance Solution, which has 6 modules. During this course, I will go through the multiple demo environments to show you some of the solution directly on the portal, such as Azure Active Directory user setting, Azure Active Directory self-service password reset, Azure Active Directory conditional access, Azure network security groups, Microsoft Defender for Cloud, Microsoft Sentinel, Microsoft Defender for Cloud Apps, Microsoft 365 Defender Portal, Service Trust Portal, Microsoft Purview, Compliance Portal, Sensitivity Label, Azure Policies, etc., etc. At the end of each segment, we will do a short review to see what we learned in this segment. But first, let me say a little about cloud security in general. Make an overview of cloud security. Why cloud security is important, what are some of the cloud security challenges, what type of cloud security solution are available, etc. Today, we are more connected than ever. Cloud security is a broad set of the technologies, policies, applications that are applied to the different online IPs, services, applications, and other data against cyber security threat and malicious activities. While cloud offers exciting opportunity for organizations to suppress the capability of on-premise environment, It's also present a new cybersecurity challenge for networking, managing, securing cloud assets. At each critical stage of your cloud transformation journey, you need to security management to stay ahead of advanced threat. Integrating cloud into your existing enterprise security program is not just about adding a few more controls or point solutions. It requires an assessment of your resources and business needs to develop a fresh approach to your culture and cloud security strategy. Question is, what's the cloud security? Cloud security is a collection of the procedures and technologies designed to address external and internal threats to business security. Organizations need cloud security as they move on to their digital transformation strategies and incorporate cloud-based tools and services as a part of their infrastructure. The terms digital transformation and cloud migration have been used regularly in enterprise. While both phases can mean different things to different organizations, each is driven by the common denominator, the need of change. As enterprises embrace those concepts and move to the optimizing their operational approach, new challenges arise when balancing productivity levels and security, while more modern technology help organizations advance capabilities outside the confines of the on-premise infrastructure. Transitioning primarily to the cloud-based environment can have several implications if not done securely. Striking the right balance requires an understanding of how modern enterprise can benefit from use of the interconnected cloud technology while deploying best cloud security practices. Why is cloud security important? In modern enterprises, there has been a growing transition to the cloud-based environment and infrastructure as a service, platform as a service, or software as a service computing modules. The dynamic nature of this management, especially in scaling services, can bring another challenges to the enterprise when adequately resourcing their environment. Those as a service modules give the organization ability to offload many of the time-consuming IT-related tasks. As companies continue to migrate to the cloud, understanding the security requirements for keeping data safe has become very critical. While third-party cloud computing providers may take on the management of infrastructure, the responsibility of the data asset security and accountability doesn't necessarily shift along with it. By default, most cloud providers follow best security practices and take active steps to protect integrity of their servers. However, organizations need their own consideration when protecting data, application, or workload running on a cloud. Security threats had become more advanced as digital landscape continue to evolve. These threats explicitly target cloud computing providers. To an organization lack of visibility of the data, access and movement. Without taking active steps to improve their cloud security, organizations can face significant governance and compliance risks when managing client information, regardless where is the stored. Cloud security should be an important topic of discuss regardless of the size of your enterprise. Cloud infrastructure supports near all aspects of the modern computing in all industry and across multiple verticals. However, successful cloud adoption is dependent on the putting into place adequate countermeasures to defend against modern cyber attack. Regardless of whether your organization operates in a public, private, or hybrid cloud environment. Cloud security solutions and best practices are a necessity to ensure your business continuity. What are some cloud security challenges? Lack of visibility. It's easy to lose track on how your data is being accessed and by whom, since many cloud services are accessed outside from corporate network and third parties. Multi-tenancy. Public cloud environment has a multiple client infrastructure under the same umbrella. So, is it possible your hosted services can get compromised by malicious attackers as a collateral damage when targeting other businesses? Access management and shadow IT. While enterprise may be able to successfully manage and restrict access point across on-premises systems, administrating the same level of the restriction can be challenged in cloud environment. This can be dangerous for organizations that don't deploy bring your own device policies and unallow filtered access to the cloud services from any device or geolocations. Compliance. Regulatory compliance management is oftentimes a source of confusion for enterprise using public or hybrid cloud deployments. Overall, cloud accountability for data privacy and security still rests with the enterprise and heavily relies on the third-party solution to manage these components to lead the costly compliance issue. Misconfiguration. Misconfigured access accounted for 86% for each records, making inadvertent insight a key issue for cloud computing in environments. What type of cloud security solutions are available? Azure offers a lot of solutions, but let's mention some of them. So like identity and access management. Identity and access management tools and services allows the enterprises to deploy policy-driven enforcement protocol for all users attempting to access both on-premise and cloud-based services. Functionality of identity access management is to create digital identities for all users so they can be actively monitored and restricted when necessary during all the interactions. End-to-end protection like Microsoft Defender for Cloud, Microsoft Defender for Cloud Apps, GitHub Advanced Security, Microsoft Entra Permission Management, Azure Network Security, Microsoft Defender External Attack Surface Management, etc., etc. Data loss prevention. Data loss prevention services offers a set of tools and services designed to ensure that security of regulated cloud data. Data loss prevention solutions use a combination of remediation alerts, data encryptions, and other preventative measures to protect all stored data, whether they are at rest or in transit. Security information like Azure Sentinel, which provides a comprehensive orchestration solution that automates threat monitoring, detection, and response in cloud-based environment. Using the artificial intelligence-driven technologies to correlate log data across multiple platforms and digital assets, security information and event management technology give IT teams ability to successfully apply the network security protocols while be able to quickly react to any potential threat. We will talk more about this during this course. Now, let's start with the first section, describe the concept of security, compliance, and identity. Module 1 describes the security and compliance concept, and we will describe the shared responsibility and defense in Dept security modules. Describe the zero trust modules, describe the concept of encryption and hashing. Describe some basic compliance concept. This is basic knowledge that has be validated through the existing cloud security standard and best practices. But first, how can we understand security and compliance concept? Security and compliance are interconnected but different from each other in a few key ways. Security refers to the system and controls that our company implements to protect its assets. And compliance refers to meeting the standards that a third party has set in advance as best practices or legal requirements. There are a number of the standards that are specifically designed to help companies create secure IT systems, as well as laws like HIPAA, for example, that have been passed to ensure that companies are doing their due diligence to protect sensitive data. While your organization may automatically adopt few security measures to help protect your business data, compliance offers strategy to bring yourself into alignment with industry best practices and to make sure that you're following the law. Organizations face many challenges with securing their data centers, including recruiting, keeping secure experts, using many security tools, and keeping pace with volume and complexity of the threats. As computing environments boom from the customer-controlled data center to the cloud, the responsibility of security is also shift. Security of the operational environment is now a concern shared by the cloud provider and customer. By shifting responsibility to Azure, organizations can get more security coverage, which allows them to move security resources and budget allocation to other business priorities. To ensure that the prepared security controls are provided, a careful evaluation of the security and technology choice became necessary. First things to understand about cloud security is that different scope of responsibility exists depending on the kind of service you use. For example, if you use virtual machine in Azure, which provides infrastructure as a service, Microsoft will be responsible for helping secure physical network, physical storage, and virtualization platform, which includes updates, virtualization hosts, but you will take the care of helping secure your virtual network and public endpoint, and updating the guest operating system of your virtual machine, etc. But for all cloud deployment types, you own your data and integrities. You are responsible for helping secure your data and identities and the cloud components you control, which vary by service type you use. Regardless of the deployment type, you always retain responsibility for the data, endpoints, accounts, and access management. Defense in depth. Defense in depth is a strategy that utilizes a series of mechanisms and prevent unauthorized access to data. The purpose of defense in depth is to protect and prevent information from being stolen by individuals not authorized to access it. The common principles used to define security posture are confidentiality, integrity, and availability. Confidentiality principle of last privilege restrict access to information only to individuals explicitly grant access. This information includes protection of user passwords, remote access certificates, and email content, etc. Integrity, the prevention of unauthorized changing to information at rest or in transit. A common approach used in data transmission is for the sender to create a unique fingerprint of the data using a one-way hashing algorithm. The hash is sent to the receiver along with data. Data's hash is recalculated and compared to the original by the receiver to ensure that the data wasn't lost or modified in the transit. And availability ensures services are available to authorized user only. Denial of service attacks are prevalent cause of the loss of availability to users. Defense in depth can be visualized as a set of the layers with data to be secured at the center. Each layer provides the protection so that if one layer is branched, a subsequent layer is already in place to prevent. For example, in the diagram, physical security is the first line of defense to protect computing hardware in data center. Identity and access control access to infrastructure and change control. Perimeter layer use distribute DDoS protection to filter large-scale attacks before they can cause denial of services for end users. Networking level limits communications between resources through the segmentation and access control. Compute layer secures access to virtual machines, and application layer ensures applications are secure and free of vulnerabilities. Zero Trust is IT security module that eliminates traditional idea of trust to protect network, application, or data. This is the contrast to the traditional perimeter security module, which presumes that bad actors are always on the untrusted side of the network, and trusted users are always on the trusted side. With Zero Trust, those assumptions are nullified and all users are presumed to be untrusted. According to Forrest Research, a Zero Trust solution must ensure that only known allowed traffic or legitimate application communication is allowed by segmenting and enabling Layer 7 policy. Also, leverage a less privileged access strategy and strictly enforce access control. Inspect and log all traffic. Otherwise, it can be very simple for an attacker to gain access to the company's network. Those principles maybe stay forward to implement in an enterprise network, but how do that play to the cloud? Your implementation must inspect all traffic for all application, or it is not truly delivered Zero Trust. Zero Trust module stay to never assume trust, but instead continuously validate trust. Trust determination components includes identity provider, device directory, policy evaluation service, and access proxy. Migrating to Zero Trust security module provides for us simultaneously implement of security over conventional network-based approach and to better enables user when they need access. Zero Trust module required signals to inform decisions, policy to make access decision, and enforcement capabilities to implement those decisions efficiently. Zero Trust module has three principles which guide how security is implemented. Those are verify explicitly, last privilege access, and assume branches. Verify explicitly allows authenticate and authorize it based on the available data points, including user identity, location, devices, services, or workload, data classification, anomalies, etc. Last privilege access limit user access, implementing just a time and just enough access. Assume branches segment access by the network using devices and application, use encryption to protect data, and use analytics to get visibility, detect threats, and improve your security. Zero Trust also serves as an end-to-end strategy based on the 6 foundational pillars. Identities, verify all identities with strong authentication. Devices, it's important to get visibility into all devices accessing your network. Application, this includes being able to discover shadow IT and the ability to control access to application and monitor access with real-time analytics. Network, this includes encryption on all your communication, limiting access by the policy and the network segmentation. Infrastructure, this includes employing real-time threat detection, automatically detecting, blocking, and flagging a risk, and employ last privilege access principle. In data, this includes being able to classify, label, and encrypt data whenever it leaves or travels. One way to mitigate against common cybersecurity threats is to encrypt sensitive or variable data. Encryption is a process of making data unreadable and unusable to unauthorized viewers. To use or read encrypted data, it must be decrypted, which required to use a secret key. Encryption at rest. What is the encryption at rest? Does the data? Does the storage on the physical device, such as server, It may be stored in a database or storage account in the cloud, but regardless of where it is stored, encryption of data at rest ensures that the data unreadable without the key and secrets needed to decrypt it. If an attacker obtained hard drive with encrypted data and didn't have access to encryption keys, that would be unable to read this data. Encryption in transit. Data in transit is data moving from one location to another, such as across the internet or through the private network. Secure transfer can be handled by the several different layers. It could be done by encrypting the data at the application layer before sending over the network. HTTPS is an example of encryption in transit. Encrypting data in transit protects it from outside observers and provides a mechanism to transmit data by limiting risk of an exposure. Encryption for data in use. Common use case for encryption data involves secure data in non-persistent storage, such as RAM or CPU caches, etc. This can be achieved through the technology that create an unclaimed. Think like security box that protects the data and keeps data encrypted while CPU processing this data. There are two levels of encryptions, symmetric and asymmetric. Symmetric encryption is use the same key to encrypt and decrypt data. Asymmetric encryption use the public key and private key pair. Either key can encrypt data, but a single key cannot be used to decrypt encrypted data. To decrypt, you need to pair it key. Asymmetric encryption used for things like transport layer security, TLS, such as HTTP protocol in data signing. For asymmetric encryption is usually used public key infrastructure or PKI, which has often hierarchy starting with the root certification server to issuer certification server. Issuer server will issue certificate with the public key until private key will stay only available for the certificate owner. Hash function is a mathematical function or algorithm that simply takes a variable number of characters called the message and converts into string with fixed number of the characters called hash value or simple hash. Hashing is useful to ensure authenticity of the piece of data and that has not been tampered. Even since small change in the message will create an entirely different hash. Hash functions are the basic tools of modern cryptography that are used in to authenticate transaction, messages, digital signature, etc. Data can be compared to the hash value to determine integrity. Usually, data is hashed on a certain time and hash value as protected on some way. At a later time, data can be hashed again and compared to the protected value. If the hash value match, the data has not been altered. If the value do not match, the data has been corrupted. For this system to work, to protect hash must be encrypted or kept secret from all untrusted party. Previously we talked about encryption, which is a reversible process, but hashing is not. Main purpose of hashing is to check the integrity of the data, whereas the main purpose of encryption is secure data by converting into an unreadable format. Password hashing is a key step to protect your user on backend, but is not unmistakable because hash is making a consistent way. That means that it's predictable and can be beaten by dictionary attack or rainbow table attack, etc. Hash salting is the act of adding the series of random characters to the password before going to the hashing function. Unfortunately, Azure AD do not support hash salting until today. Once a company is on the cloud, it should be concerned with how the cloud help company remain in compliance with the laws, such as Europe General Data Protection Regulation, or HIPAA in US. This discussion should start from very beginning rather than after the cloud service is established. Government agency and industry groups had issued regulation to help protect and govern use of data from personal and financial information to data protection and privacy. Organization can be accountable for meeting dozens of regulations to be compliant. Some of the important concepts in turn that related to data compliance are data residency, data sovereignty, and data privacy. Data residency, when it comes to compliance, data residency regulations govern the physical location where data can be stored and how will be transferred, processed, or accessed internationally. This regulation can differ significantly depending on jurisdiction. Data sovereignty. Another important consideration is data sovereignty. The concept of the data, particularly personal data, is subject to the law and regulation of the countries or region where is the physically collected or processed. This can add a layer of complexity when it comes to compliance, when the same piece of data can be collected in one location, stored in another location, processed in still another, etc., making it subject to laws from the different country or regions. Data privacy, providing notice and being transparent about the collection, processing, use, and sharing of personal data are fundamental principles of privacy laws and regulations. Personal data means information related to identify natural person. Privacy laws expanded this definition to any data that is directed, linked, or indirectly linkable back to the person. Organizations are subject to and must operate consistent with a multitude of laws, regulations, goals of conduct, industry-specific standard, compliance standard, government data privacy, etc. Now let's move to the module 2, describe identity concept. We will briefly discuss about understanding the differences between authentication and authorization, describe the concept of identity as a security perimeter, and describe identity-related services. But first, generally, what and who is the identity? Anything that can be authenticated. It can be user, application, or services that require authentication. Everyone and every device has an identity that can be used to access resources. Identity is the way in which people and things are identified on your corporate network and in the cloud. Being certain about who or what accessing your organization data and other resources, that's the fundamental part of securing your environment. Authentication is a process of the proving that you are who you say you are. This is achieved by the verification of identity on the person or device. It's sometimes shortened to AuthN. Microsoft Identity Platform uses OpenID Connect protocol for handling authentication. Authorization is an act granting an authenticated party permission to do something. It specifies what data you are allowed to access, what you can do with this data. Authorization is sometimes shortened to AuthZ. Microsoft Identity Platform uses OAuth 2.0 protocol for handling authorization. Difference between authorization and authentication authorization simply means first, authentication is a process to verifying who someone is, whereas authorization is a process of verifying what specific application files or data user can access. Ensuring secure identity and mobile access is top-notch and convenience explicitly at the internet scale can be adapting task for IT executives. Enterprise must define the line between enterprise control and granted access or permission to the individuals. The result is that the identities becomes new security perimeter. Only identity can both enable organizations to secure resources while giving end users convenience and easy of use approach. Enterprise security needs to adopt a new reality. The security perimeter can no longer be viewed as an on-premise network. It's now extended to the SaaS applications for business-critical workload that may be hosted outside of your corporate network. Extending also personal devices for employers using to access to corporate resources. We call this bring your own device or while working from home. Extending also to unmanaged device used by the partners or customers when interacting with corporate data or collaborating with your employees. And also extending to IoT devices installed through your corporate network and inside customer location. 4 pillars of identity are administration, authorization, auditing. Administration is about creation and management of identity for users, devices, and services. As an administrator, you manage how and under what circumstances characteristics of identities can change by creating, update, or delete. Authentication pillar tell the story on how much assurance for particular identity is enough. Authorization pillar is about processing incoming identity data to determine the level of access and the person or service has within an application or services that has access. And auditing pillars is about tracking who does what, when, and how, and also auditing include in-depth reporting, alerts, and governance of identities. Modern authentication is an umbrella term for authentication and authorization method between clients such as your laptop, phone, server, like website or application, etc. At the center of the modern authentication is the role of your identity provider, and identity provider creates, maintains, and manages identity information while offering authentication, authorization, and auditing services. With modern authentication, all services, including all authentication services, are supplied by the central identity provider. Information that's used to authenticate a user with server is stored and managed centrally by identity provider. With the central identity provider, organization can establish authentication and authorization policy, monitor user behavior, identify suspicious activities, and reduce malicious attacker. When the identity, which can be user or application, has been verified, the identity provider issues a security token that the client sends to the server. The server validates security token through its trust relationship with identity provider. By using security token and information that's contained with it, the user or application access required resources on the server. Microsoft Azure Active Directory is an example of cloud-based identity provider. Other examples include Twitter, Google, Amazon, LinkedIn, GitHub, etc. There are also single sign-on capability. That's the fundamental capability of an identity provider in the modern authentication, which supporting single sign-on. In single sign-on, user logs in one, and then credential is used to access multiple applications or resources. When you set up a single sign-on between multiple identity providers, it's called simple federation. To avoid any confusion with Windows Server Active Directory that you may already be familiar with, understand that the Azure Active Directory is not the Windows Server Active Directory running on your virtual machine or on your premise. Azure Active Directory is not a replacement for Windows Server Active Directory. If you already have on-premise Active Directory domain system, directory can be extended to the cloud using directory integration capabilities of Azure Active Directory. In those scenarios, users and groups in on-premise Active Directory are synchronized to Azure Active Directory using the tools such as Azure Active Directory Sync, AD Sync. This has the benefits for user being able to authenticate against Windows Server Active Directory when accessing on-premise applications and resources, and authenticating against Azure Active Directory when accessing cloud-based applications. Azure Active Directory is different from Active Directory domain services. Azure Active Directory is a primary and identity solution and designed for internet-based application by using HTTPS communications. Because Azure Active Directory is HTTPS based, it cannot be queried through the LDAP. Instead, Azure Active Directory uses REST API over HTTP and HTTPS. Also, it does not use Kerberos authentication. Instead, it uses HTTP and HTTPS protocols, such as SAML, Windows Service Federation, and OpenID Connect for authentication, and OAuth for authorization. There is also no organization units. Azure Active Directory user and group are created in flat structure in Azure Active Directory. Federation is collection of the domains that have established trust. The level of trust may vary, but typically includes authentication and almost always include authorization. Typical federation may include numbers of organizations that have established trust for shared access to set of the resources. You can federate your on-premise environment with Azure Active Directory and use this federation for authentication and authorization. This sign-in method ensures that all users' authentication occurs on-premise, and this method allows the administrator to implement more rigorous level of access control. Many organizations use Active Directory Federation service to provide single sign-on. Establishing relation between two different domains we call trust relationship. This trust is not always bidirectional, but you can establish bidirectional trust relationship. Previously, we called this two-way trust relationship. This concludes the first section of this course. Before we move on to section 2, let's give a quick overview of what we learned so far. Just a few segments to stay fit. Considering shared responsibility module on Azure Cloud, we can conclude that your organization is still fully responsible for account identities related to your employees and your information and data regardless of where your workload is hosted on IaaS, PaaS, or SaaS. Until Azure is fully responsible for a physical data center, network, and hosts, in other words, for underlying infrastructure. We learned too, if you want to ensure that the stored data is encrypted, you should use encryption at rest, because encryption in transit is intended for data that travels over the network and not for data on the storage. And also, hash is not used for encryption, because hash does not encrypt data. In terms of compliance concept, we learned, among other things, that the concept of data sovereignty refers to data, particularly personal data, which is subject to the laws and regulation of the country or region in which is physically collected, held, or processed. We have learned that the advantage of the single sign-on is a great benefit for all users, because the users sign in once and can access many applications or resources. We also learned that the relationship allowing federated services to access resources, we call this trust relationship. We also learned that authentication is a process verifying that user or device is who they are, say they are, and authorization determined what it can do with certain resources.